Hello everyone, I am Dr. Mangesh Joshi from Department of Mechanical Engineering and welcome to online lecture series on data structure and algorithm. So in this course we are going to deal with different course outcomes. First of all, let us see the course objective. So course objective is to equip students with the knowledge and skills to design, implement and analyze fundamental data structures and algorithms, enabling them to efficiently solve complex problems and optimize performance in computational applications. The course outcomes of this course, that is, identify different ADTs, that is abstract data types, their operations and specify their complexities. Second, apply linear data structures, that is array, linked list, queue, stack, to address practical challenges and analyze their complexity. Third, implement different sorting, searching and hashing methods and analyze their time and space requirements. Last, analyze non-linear data structures to develop solutions for real-world applications. Let us begin with the first topic, that is data structure and algorithm basics. So data structure is about how data can be stored in different structures. Now you know that there is different type of data in different situation. For example, if you consider IMDb ratings, that is a movie database, so it may take a shape of a table. If you consider the example of, let's say, GPS system, so it may take some form of something like this. That is, there will be some starting point, there will be some ending point and likewise, right? So depending on the type of data, the different data structure is required. Next is algorithms. So it is about how to solve different problems, often by searching or manipulating data structures. Now combining data structure and algorithm will help us to manage large amount of data to solve problem efficiently. Before moving on further, let us understand the basic terminologies which is going to be used. First of all, algorithm, you already know this. That is nothing but a sequence of well-defined steps designed to solve a particular problem. Next is data structure, a method of storing and organizing data for efficient access and modification. Examples of data structure: arrays, linked list, binary trees, etc. Then time complexity, an estimate of the time an algorithm requires to execute based on the size of the input data. Then next is space complexity, an estimate of memory an algorithm consumes relative to the size of input. Next is big O notation, a symbolic representation used to describe upper bound of an algorithm's time and space complexity as the input size grows. Recursion, we have already seen this in programming for problem solving. It is nothing but a coding technique where a function repeatedly calls itself to solve smaller instances of a problem. So in this, the problem is solved in a stepwise manner by calling itself. Next terminology is divide and conquer, a problem solving strategy that breaks a problem into smaller sub-problems, solves each one individually, and then combine the result. So if there is a big problem, we will solve or we will divide this big problem into small sub-problems and then we will solve each problem individually, right? Lastly, the brute force, basic approach to problem solving that involves checking all the possible solutions to find the correct one. So every problem has multiple solutions, may or may not have multiple solutions. So we need to check all possible solutions and to find the optimal one, which is nothing but brute force. The second part of this lecture is elementary data organization. So elementary data organization refers to the basic ways in which data can be grouped, stored, and managed inside a computer's memory. For example, if you have a pile of books or list of names, how you choose to arrange or organize them will affect how easily you can find it, use it, or update it. The same logic applies to data in a computer programs. So for example, if you're having a fridge, so there is one separate compartment for items which requires less temperature. So you may keep here ice or some milk or some ice creams. Then there is one compartment for storing milk, for example, milk related products, that is milk, then paneer or cheese or something like that, curd. Then there is separate compartment for keeping bottles. Then there can be a separate compartment for keeping fresh vegetables. So if you arrange your items in this fridge as per this, what it will make, it will help you to for easier finding it, easily using it, and easily adding or removing items from the fridge, right? The same logic applies to data in computer programs as well. So you have to systematically group it, store it, and manage it. Then types of this elementary data organization: primitive type and non-primitive type. You already know the primitive type: integer, character. Boolean is nothing but true or false, or 1 or 0 types, right? Then float and pointer. In the non-primitive type, it is divided into two types: linear and non-linear. Inside linear, we have static and dynamic. Inside static, we have array. Once the array is declared, for example, if you declare array of 5, then the size of array you cannot change. The number of elements inside the array you cannot change. So that's why it is termed as static. Whereas on the other hand, the dynamic type, here you have linked list, stack, and queue. So the meaning of this dynamic type is the number of elements can be added or deleted depending on the need. So each, if you take example of linked list, so each element is arranged in this fashion. So you just go on adding the nodes to the data structure, and you can have number of items. Similarly, stack, it is just a vertical arrangement of data. So first data is inserted here. So it follows last in first out principle, right? So last operation that you have performed or last data you have added, it will go out first. So just to explain this stack in just 120 or 20 seconds, suppose you have an Excel file and you have performed some operations over here. Suppose you have modified something here, likewise. So the undo operation, when you press Ctrl Z, what it does, it undoes the last operation performed by the user. So this is nothing but example of stack. So stack will keep the record of operations done by the user, and whenever you press Ctrl Z, it will undo the last operation done, and then previous, and then previous, likewise. Then is last one is queue inside the dynamic type. It is nothing but ensuring first in first out. The data comes first in will go out of the system first. If we take a real life example, if you go to the bank, right, so first customer will be given first priority and he will be out of the system first, right? So this is the example of queue. So there are different types of linked list also, queue also, that will be seen in the separate lectures. Inside non-linear, we have tree and graph. So the data is arranged in tree-like fashion, inverted tree-like fashion. It is called as tree. and I have already given you example of graph, that is your GPS system. This kind of arrangement of data is called as graph. So data structure is about how data can be stored in different data structure. I have already explained this: arrays, linked lists, stacks and queues, hash tables, trees, graphs. Then algorithms, there are different searching algorithms, sorting algorithms, divide and conquer algorithms, hashing, greedy and backtracking algorithms. So main purpose of algorithm is step-by-step instruction to solve a given problem to achieve specific goal. So data structure and algorithm together helps us to manage large amounts of data to solve problems efficiently. A data structure is not worth much if you cannot search through it, manipulate it efficiently using algorithms. And algorithms are not worth much without a data structure to work on, right? So both are independent of each other. By understanding DSA, you can decide which data structure or algorithm is best for a given situation, make programs that run faster or use less memory, understand how to approach complex problems and solve them in a systematic way. So where is this data structure and algorithm needed? So there are a number of applications, real life applications where this DSA is useful. So first application is web development, which is used by many students, right? So you often go on to Google and search something. So you might have used Google, Yahoo search engines, but only Google is very popular due to the speed of searching. So the algorithm that Google uses is very efficient and gives you the result in very quick manner, right? So implementing a search bar on a website is an example. Second application is mobile apps. Everybody uses WhatsApp in day-to-day life. The concept of linked list is used in this chat. So one chat is nothing but called as a node, and each node is connected to other node, right? So you can delete any node or you can add more number of nodes as messages came in, right? So this linked list can be used to manage the messages dynamically as new messages are added or deleted depending on the need. Third popular application is e-commerce, that is product recommender, recommending products based on user behavior. So you might have been went on Amazon and you have suppose searched for a pencil. So a recommender system may also suggest you a pencil holder or a notepad or some item which are similar to it, right? So that is an example of recommender system. So that basically uses the graph. In e-commerce, graphs can be model relationship between users and products for recommendation. If you go on Instagram, if you watch certain reels, so depending on the type of reels you are watching, so the recommender system inside Instagram will suggest you similar kind of reels, right? So this is one application. Next application is gaming application. So path finding for characters or objects. So graph traversal algorithms like breadth first search, depth first search help find the shortest or most efficient path. Fifth application is banking, that is managing customer transactions. I have already explained you the queues. So queues are used to handle multiple requests. So first request will get the first priority and it will be resolved first. So first in first out manner. Sixth application is navigation system, finding the shortest route on Google Map. So Dijkstra algorithm is used to calculate the shortest path between 2 points on the map. So map suggests you the shortest distance or shortest path which will you take you to the destination at shortest possible time. Then lastly, we have different data structure operations. So any data structure should allow certain basic operations. So traversal, insertion, deletion, searching and sorting. These are all basic operations which can be performed on the data structure. Traversal, accessing each element once. Insertion, adding a new element. Deletion, removing an existing element. Searching, finding an element. Sorting, arranging elements in a particular order. So these first four are very essential. The programmer can add, depending on the need of the situation, different algorithms to it. So first four are mandatory. Sorting plus other operations can be added by the user depending on the need, right? So I hope you have understood this video lecture. Thank you for watching this video. If you have any queries, you can comment in the chat box, right? Or thank you and have a nice day.